Hello everyone, Constructechnos Forum welcomes all you construction technocrats. Today we will discuss about a software developed on Excel with Visual Basic. It is developed for the design of horizontal curves for railway alignment. Curves form a indispensable component of railway alignment. It is desirable but not always possible to follow the straight alignment. The alignment has to be changed by introduction of curves due to various techno-economic reasons. This software has been developed for the field engineers, whether in construction or maintenance of railway curves. The main features of this software are design of simple circular curve, design of compound curve, design of transition curve, design of S curve, speed potential of track, equilibrium speed of track, calculation of cant, graphic representation of curve fittings, and transferring graphical presentation to AutoCAD. And most importantly, it is very easy to operate. Even a beginner level of Excel user can operate it. And of course, it is almost free. So let us see how this software works and how to operate it. On the first sheet, some highlights are given which are taken from railway code and guidelines. These are some important guidelines that are needed while taking decisions of curve design. The second sheet is for initial calculations. To begin curve design, we calculate some unknowns based on what is already known. This sheet is for that initial calculations. This sheet is self-explanatory. Using this, you can automatically find out its various uses. The next sheet is speed and transition. This is the main sheet where we design our curve and transition. First of all, we select the track category for which we have to design the curve. For example, I am selecting B here. If this is not known, you can design for the general cases by selecting the hash. Then enter the required speed for which you are designing the curve. For sectional speed, let us consider 120 kmph here. If you want to design for an equilibrium speed, enter your required equilibrium speed here, otherwise you can ignore it. Now enter your minimum speed, which is generally the speed of goods train in your section. I am taking 65 kmph here. In fact, this is necessary for mixed traffic condition. If in your case there is no mixed traffic, then you can also type 120 here, which is same as above sectional speed. After this, you have to give the radius of the required curve. Suppose the radius of our curve is 560 meter. So let us enter 560 here. So we have provided all the necessary inputs to the computer, and now we have to design the curve. To do this, you just need to click on the calculate icon here. Now the computer starts calculating based on the input given by you. After the calculation is complete, you can see two columns of output here. One is for calculated value and the other is for adopted value, which is based on the limits given in the railway guideline after rounding off to the final value. Finally, we got all the results here. Now one must see that the final calculated speed is shown in orange color. The orange color indicates that the calculated speed is not matching the speed for which we are designing the curve. What do we do now? To achieve the required speed, we have to increase the radius. But what will be the radius? Well, you don't need to take any stress. Simply delete the radius and run the program again. The computer itself will suggest the radius for you. The computer suggests 805 meter, which is very close to our required speed. This means that a small increase in radius will produce the required result. So click on the fine tune. The computer suggests a radius of 813 meter. So make it 813 and calculate again. Now you can see that the required speed of 120 kmph has been achieved. Now we have CA, CD and speed. Based on this data, we will decide the details of the transition to be provided. Everything has been calculated automatically and we get a transition of 140 meter. Here you can see that both the RDSO criteria for transition have been met here. But sometimes it happens that you do not have enough space to provide the entire length of the transition. In that case, our PWA manual allows to provide shorter length of transition with minimum limiting length as calculated here. All the three options for transition length are available in this drop down list. You can select it from here. The first is the desired length, the second is the minimum allowed length and the last is the virtual transition length. Suppose we are choosing the second option here, that is 95. Now you can see that both parameters are grayed out instead of green. This faded or grayed color indicates that your selected length is less than desirable but still within acceptable limits. Let us see what happened when we make it 50. See, both parameters turned red, indicating that are not matching the specification. Okay, now make it 60. One criteria is being met but the other is not, therefore cannot be accepted. Even 70 or 80 is not meeting the criteria. So make it again 95, which is the minimum transition required. Now whenever we provide a length shorter than desirable, it becomes mandatory to verify the suitability of the given transition as shown in the next step. First, we pull in the data we need by clicking on this downward orange arrow. When the orange color of the arrow fades, it indicates that the data has been pulled. At the end of this box, we can see that after all the calculations, we are getting a speed of 120 kmph with a cant of 145 mm with this restricted transition length. Now we will calculate the transition details needed to fit it on the ground. For this, we will once again click on this down arrow and drag the data here. You can see that all the offsets have been calculated here for this delta or deflection angle. The deflection angle can be anything for your case. That's all. Now we have a complete calculation of curve, transition, cant and speed potential. So what is next? Before sending these calculated results to the draftman or field supervisor, it would be better to verify it graphically. But how? Very simple. Click this icon. The computer will take you to a sheet called Simple Curve. As usual, drag the calculated data here by clicking this arrow. Next, click here and the calculation will start. Wait for a few seconds. Feed the interval of offset as required. The default value is 5 meter. I am changing it to 10 meter. Wait again for a few seconds and all done. Now you can see your curve fitting graphically here. And now what is next? Now this entire curve fitting has to be transferred to AutoCAD. For this, just click on this icon and your entire data will be transferred to the already opened AutoCAD file. Open your AutoCAD file and here is your curve fitting with transition and curve details. There is some more features which will be covered in the next part, but you can also understand easily by using those icons. See you soon with its second part. Till then, goodbye. Jai Hind, Jai Bharat.